This is section 10.2, part C, significance test for mu1 minus mu2. An observed difference between two sample means can reflect an actual difference in the parameters of mu1 and mu2, or it may be just due to chance variation in the random sampling or random assignment. Significance tests help us decide which explanation makes more sense. To find the p-value, use the t-distribution with the degrees of freedom given by the degrees of freedom of the smaller of your two samples. So remember, to find the degrees of freedom, you're going to take your sample size minus 1. Whichever one of those is the smaller value is what you will use for degrees of freedom. Here are the details for a two-sample t-test for the difference between two means. So suppose that the random, normal, and independent conditions have been met. To test the hypothesis of mu sub 0, or h sub 0 is mu sub 1 minus mu sub 2 equals the hypothesized values, compute the two-sample t statistic with the following equation. Find the p-value by calculating the probability of getting a t-statistic this large or larger in the direction specified by the alternative hypothesis h sub 0. Use the t-distribution with degrees of freedom given by the smaller of the two samples. So remember, if our alternative hypothesis is that mu1 minus mu2 is greater than the hypothesized value, you're finding the area to the right, which is actually what's given on the t-table. If it's finding the value that is less than, or the area to the left, you are going to have to find the area to the right, but the left side is symmetric. And if it is not equal to, you will find the area to the right, and then you'll just have to multiply it by 2 because there are two tails. Does increasing the amount of calcium in our diet reduce blood pressure? Examination of a large sample of people revealed a relationship between calcium intake and blood pressure. The relationship was strongest for Black men. Such observational studies do not establish causation. Researchers therefore designed a randomized comparative experiment. The subjects were 21 healthy Black men who volunteered to take part in the experiment. They were randomly assigned to two groups. 10 of the men received a calcium supplement for 12 weeks, while the control group of 11 men received a placebo pill that looked identical. The experiment was double-blind. The response variable is the decrease in systolic, or the top number, of the blood pressure for a subject after 12 weeks, in milliliters of mercury. An increase appears as a negative response. So if their blood pressure actually went up, this is going to show as a negative value. If their blood pressure went down, it's going to show as a positive value. Here are the data. So, for part A, a Fathom dot plot is shown below. Use the graph to answer these questions. Are the centers of the two groups similar or different? Explain. And are the spread of the two groups similar or different? And please explain. So the centers of these two groups are different. The calcium group is centered at a blood pressure decrease value greater than 0, while the placebo group is centered at a value less than 0. So as you can see, the center of this one is less than 0. The center over here is definitely greater than 0. The spread are similar though. So if you look at the value or how big this spread is, those spreads are the same. So both groups have a range of decrease in blood pressure of about 25 milliliters of mercury. Do the data provide sufficient evidence to conclude that a calcium supplement reduces blood pressure more than a placebo? Carry out an appropriate test to support your answer. So this will be a 4-step problem. Remember, in the state, when we are doing a test, we need to give the null and alternative hypothesis. You need to define your parameter, and you need to give a significance level. So we want to perform a test of h sub 0 is mu1 minus mu2 equals 0, so there's no difference, versus the alternative, we think the calcium is going to be greater than 0 because we think there's going to be more difference. So our alternative hypothesis will be mu1 minus mu2 is greater than 0. where mu1 is the true mean decrease in systolic blood pressure for healthy black men, like the ones in this study, who take a calcium supplement, and mu2 is the true mean decrease in systolic blood pressure for healthy black men, like the ones in the study, who took a placebo. Since there was no significance level specified, we're going to let alpha equal 0.05. Next is when we make our plan. Remember, you should always start your plan with what method you're going to use first, and then you need to check your conditions. So if the conditions are met, we will carry out a 2-sample t-test for mu1 minus mu2. Now, it does need to check the random, normal, and independent. The 21 subjects were randomly assigned to the 2 different treatments, so the random component has been met. For the normal component to be met, both samples would need to be at least 30. Since one sample has 11 and the other one only has 10, we are going to have to graph them and check for any strong skewness or any outliers. And as you can see from the graphs, there is no strong skewness, there are no outliers, so we can go ahead and use the normal condition. So we can use those T procedures. For independent, due to the random assignment, these 2 groups of men can be viewed as independent. Independent observations on each group should also be independent. So knowing one subject's change in blood pressure doesn't give us any information about the other subject's response, so we do have independence within the group as well. Next is the do part of our problem. The first thing we need to do is find our degrees of freedom. Now, our degrees of freedom, remember, is the sample size minus 1. So we have degrees of freedom of 9 for group 1 and degrees of freedom of 10 for group 2. You are always going to pick the smaller of the degrees of freedom. So when we look, you are going to look at degrees of freedom of 9. Next, you need to find that test statistic. So we're going to use this formula. We're going to plug in all of our information from our variables. So in your calculator, you would have to put in group 1, and you would have to calculate their mean and their standard deviation. And the mean for group 1 was 5, or if they gave it to you, so they gave it to you in this table. So our mean is 5, and our standard deviation is negative 0.273. I'm sorry, the standard deviation is 8.743. For group 2, the mean is negative 0.273 with a standard deviation of 5.901. So if we plug that all in, you will get a test statistic of 1.604. Now, if you go to your T table, you go to degrees of freedom of 9, you're going to go across that row until you find where 1.604 would lie. And 1.604 would be somewhere between 1.383 and 1.833. So if you go to the top, it's going to tell you the p-values. So we do know that our p-values are going to fall between 0.05 and 0.10. So we know that 0.05 is less than p, our p-value, which is less than 0.10. So based on this p-value, we will write our conclusion. So because the p-value is greater than alpha equals 0.05, we fail to reject the null hypothesis. The experiment provides some evidence that calcium reduces blood pressure, but the evidence is not convincing enough to conclude that the calcium reduced blood pressure more than the placebo. Now, technology gave a p-value of 0.0644 for the test in Part B. Interpret this value in context. So, assuming that our null hypothesis of mu1 minus mu2 equals 0 is true, the probability of getting a difference in mean blood pressure reduction from the 2 groups, calcium minus placebo, of 5.273 or greater just by chance involved a random assignment is about 0.0644. So there's a chance of about 6% that this could happen just because of the random assignment. Let's check our understanding. How quickly do synthetic fabrics such as polyester decay in landfills? A researcher buried polyester strips in the soil for different lengths of time, then dug up the strips and measured the force required to break them. Breaking strength is easy to measure and is a good indicator of decay. Lower strength means the fabric has decayed. For one part of the study, the researchers buried 10 strips of polyester fabric in well-drained soil in the summer. The strips were randomly assigned to 2 groups. 5 of them were buried for 2 weeks, and the other 5 were buried for 16 weeks. Here is the breaking strength in pounds for each group. Do the data give good evidence that polyester decays more in 16 weeks than in 2 weeks? Carry out an appropriate test to help answer this question. Once again, we are going to have to do a 4-step problem. We're going to start with our state. Remember, in your state, you need to give the 2 hypotheses, you need to define your parameters, and you need to give a significance level. So for our state, we want to perform a test of h sub 0 is mu1 minus mu2 equals 0 versus the alternative hypothesis, mu1 minus mu2 is greater than 0, where mu1 is the true mean breaking strength at 2 weeks and mu2 is the true mean breaking strength at 16 weeks. So we think that the breaking strength is going to be stronger at 2 weeks than 16 weeks, which is why we said greater than and not equal to. No significance level was specified, so we will use alpha equals 0.05. Next is the plan. You need to state what method you want to use, and then you need to check your conditions. So if the conditions are met, we will carry out a 2-sample t-test for mu1 minus mu2. There are 10 strips of polyester that were randomly assigned to the 2 treatments, so our random condition has been met. Since each sample size is only 5, we are going to have to examine the data. From the dot plot, neither group displays strong skewness or any outliers, so we are good to go with our T procedures. And we need to check for independence. Due to the random assignment, these 2 groups of pieces of cloth can be viewed as independent. But within each group, we also need to check for independence, and knowing the breaking strength of one piece does not let you know the breaking strength of another, so those are also independent of each other. Next is the do, where we're going to have to actually do the calculations. From our calculator, so you will have to put this into your calculator, for each group you will have to find the mean and the standard deviation. And then from there you will have to calculate your test statistic. And to do that, you're going to use this formula. Now that mu1 minus mu2, this piece right here, is just whatever your null hypothesis was. So our mu1 minus mu2 in our hypothesis was that it was 0. Everything else you're going to have to get from your information. And we're going to get a test statistic of t equals 0.989. Before you go to the t tables, you are going to have to find your degrees of freedom. And remember, degrees of freedom is equal to n minus 1. So for the first sample, our sample size was 5, so our degrees of freedom is 4 for that one. Group 2, the sample size is also 5, so it also has a degrees of freedom of 4. Because they're the same, you're just going to pick 4, but remember, if they are different, you're always going to pick the smaller degrees of freedom. And if you look at table B, if you look at the line for degrees of freedom of 4, you're going to go over until you find a t-value of 0.989. And you're going to see that if you look at the top, it's going to fall between the p-values of 0.15 and 0.20. And this is just a one-tailed test, so we don't have to do anything else with those numbers. So now we need to make a conclusion based on our p-value. Since our p-value is greater than 0.05, we fail to reject the null hypothesis. We do not have enough evidence to conclude that there is a difference in the actual mean breaking strength of polyester fabric that is buried for 2 weeks and fabric that is buried for 16 weeks.